Hey guys, so today's lesson is continuing on with our triangles discussion. Last time that we talked about triangles, we were talking about how to solve for angles that were missing. So we know that inside of a triangle, so we have a triangle, inside all the angles, when we add the angles together, have to equal 180 degrees. Doesn't matter what type of triangle it is, they always have to equal 180. What we're going to talk about today is how to create a triangle or identify if it can be a triangle or not based off of side measurements. So I have these sticks that connect together, and we're going to play around with them, and we're going to take a notice of the lengths of each of the sticks. So each stick represents a side, and we're going to identify if it can create a triangle or not. So I'm going to go ahead and pan it down onto the paper so you guys can see it a little bit easier. We're going to make some notes, and then we're going to identify what the rule is for whether it is a triangle or not a triangle. Okay, so let's start with the one that I was just showing you. So we have a brown that happens to be our longest measurement. So if I take these apart, the brown that I have here happens to be the longest one. The red is a middle measurement, and the blue happens to be shortest. So we have three sides that we would try to connect together, and we want to see if they will form a triangle or not. So what I do is I'm going to take the ends of each of these sticks, and I'm going to connect them together. So obviously I can connect all of these together. Now I want to see if I can connect the third to form a triangle, which in this case I can. So having these measurements will form a triangle. So what I want to take a look at is just the short ones. So if I'm looking at the two shortest, remember we said the red and the blue were shorter than the brown. But if I put the red and the blue together, they then become longer than the brown. So the brown side is supposed to be our longest measurement, but the red and the blue together are going to outmeasure that brown. That's a really important feature to understand. So these created a triangle. Let's take a look at this one. So I have a red and I have two purples. So if I have two sides that are the same, we would call that an isosceles triangle, right? If it can form a triangle. So the red is obviously longer than the purple. So I'm going to connect the purple to the red, connect this purple to the purple, and see if I can connect them to the red. And when I do so, I can't form a triangle. So if you notice, together, the two purples are equal size measure of the red. So that's important. The two purples were supposed to be my shorter sides, and if I put them together, they are equal in measure to the red side. And they did not form a triangle. Okay, so let's start making some notes. So we noticed that if we had the two short sides, the two shortest sides together were longer than the longest side. When we had that, so this was our first triangle, or our first attempt at creating a triangle. So that was the brown and the red and the blue. These two sides that were shortest, when put together, they were longer than the longest side, and it formed a triangle. Forms a triangle. Now we have example 2. With example 2, we had the two shortest sides. When we put them together, their measurement were equal to the longest side. And it did not form a triangle. So that was important. When the two shortest sides had a measurement that's equal to the longest side, when we put the two short sides together and it's equal to the longest side, it does not form a triangle. Okay, let's take a look at another one. So for here, we've got a yellow one. We have a green one that's shorter, and an orange that's even shorter than that. Okay, so before I even try connecting them together, let's take the two shortest sides and put them together. And notice, hey, the two shortest sides, when I put them together, are they longer than the longest side? Yes. So should it be able to form a triangle? Yes, it should be able to form that triangle. So let's try it out. I'm going to connect those together, and look at that. It's a scalene triangle. All three sides are different measurements, and it forms a scalene triangle. Okay? Let's take a look at another one. Let's take this brown, a yellow, and a light green. So we've got the brown, the yellow, and the light green. Let's see if it's going to form one. I'm going to put the two shortest sides together so that I can take a look. When I have the two shortest sides together, is it longer than the longest side? No. Is it equal to the longest side? No. So do you think it's going to be able to form a triangle at all if we piece them together? Not even close. Okay, so the two shortest sides, in this case, the two shortest sides together were not longer than the longest side. So it can't even reach to the very end of the longest side. So it was not able to form a triangle. So let's make that third note. The two shortest sides together were shorter than the longest side. And in that case, it did not form a triangle. So it seems the only way that we can actually form a triangle is if your two shortest sides, when we piece them together, will be longer than your longest side. That's the only way it can form a triangle, is for those two shortest sides to create a measurement that is longer than your longest side. So it has to always follow rule 1 in order for it to be a triangle. The two shortest sides together needs to create a measurement that's longer than the longest side in order for it to form a triangle. So let's write that down as a rule. So if we put something together, what operation does that mean we're doing? Addition. We're adding. So it's called the sum. The sum of the two smallest or shortest sides needs to be greater. So it is greater or larger or longer than the largest side. Okay, the sum, which means adding, the two smallest sides together, needs to create a value or a length that is greater or larger than the largest side. So let's take a look at a couple of examples, some actual values, and we're going to decide, is it able to form a triangle or not form a triangle? Okay, so we have 7, 18, and 15. So the first thing I want to do is find the sum of the two smallest sides. So if I have 7, 18, and 15, my smallest sides are 7 and 15. Those are my smallest sides. So I'm going to add those together. 7 plus 15. 7 plus 15 is going to give me 22. So now I need to check, is 22 greater than the largest side? Well, my largest side is 18. So is 22 greater than 18? Is this a true statement? 22 is greater than 18. Yes, this is true. So is this going to form a triangle? Yes. Because it is a true statement, because it is greater, we want it to be greater than the largest side, it will form a triangle. So this is a triangle. Okay, let's take a look at another problem. We've got 17, 5, and 12. 17, 5, and 12. So let's take a look. Again, we want the sum of the two smallest sides. Our two smallest sides are 5 and 12. So if I take 5 and I add 12, that's going to give me 17. 5 plus 12 is 17. Well, in this case, my largest side is 17. So we've got 17 is not greater than the 17 for the largest side. So since it's not greater, then no, this is not a triangle. This is not going to be a triangle. Let's take a look at another example. We have 14, 2, and 9. 14, 2, and 9. So take the two smallest sides, 2 and 9. We're going to add them together, 2 plus 9. That's going to give you 11. Our largest side is 14. Is 11 greater than 14? No. 11 is not greater. It is not greater than 14. And therefore, this is not a triangle. Okay, we'll do one more example. We have 13, 17, and 19. Okay, so my smallest sides are 13 and 17. Those are my shortest lengths. If I take 13 and I add 17, I'm going to get 30. My longest side is 19. Is 30 greater than 19? Yes, 30 is greater than 19. So yes, this is a triangle. Okay, so today's assignment, you're going to just be identifying whether or not it's a triangle or not a triangle based off of the side lengths that are given to you. It's a very quick assignment. And then there's also going to be a review assignment that's covering all the things that we have learned on cross sections, on solving for missing measurements inside of a triangle, solving for missing angle measurements given complementary, supplementary, or vertical angle relationships.